Hey, this is Craig. I'm going to talk a little bit about what we're doing this afternoon. First, I'm going to tell you that we purchased a 2,000 watt fiber laser from Skyfire, and we took possession of that about 3 months ago, and we've been using it as a welder, and it works great for that. And we decided to try it out as a cutter because it can be a cutter and a laser welder. So we mounted it on a 6-axis ABB robot, but that turned out to be pretty hard to program and get that to work right. So we decided last couple of days, let's just try to mount it on our Crossfire Pro, which is what I have here. And this laser is inherently dangerous. It's 2,000 watts. I can't stress enough, this demands respect, and you have to take your safety seriously. This could definitely burn you. It could blind you. It could kill you under certain circumstances. And in this video, I'm going to talk a little bit about what I did, but I'm not going to go into specifics, nor am I going to answer questions. If you can't figure out what I did from the documentation that Skyfire sent you and the operation of this laser, if you can't figure that out by yourself, you probably should not be doing this swap out. All right, because it's a safety concern, and I'm not gonna go into details about that, other than the fact that I have this whole system running on this Crossfire Pro Languir Systems control system, and all we did was we have to run without the torch height control on. I will say that we have 3-phase 240 volt power in our shop, and I built this little tester so I could check the actual the phasing wires on our outlets here, because we have probably 20 different 3-phase outlets here in the shop. And that shows you all the phase-to-phase voltages. And all I'm going to say is one of these is a wild leg, and I'm not going to go into what that means. And you have to have you have to have this wired correctly. And if you don't understand that part either, don't do this solution. Okay. I've been doing this industrial control like this for a long time, and I'm not going to tell you what I ended up doing, but I will say that we're running this on 3-phase 240 power. All right, so the first thing we did was we disconnected the machine torch, and we put it up on the beam up, the cable beam up there, and we were just running it, the fiber bundle, and my business partner here was just holding the fiber bundle. And this fiber bundle is pretty fragile, so you want to make sure you protect it. And we are running our laser, it's 2,000 watts, but we're running it at 1,500 watts. And our primary workflow is to take a flat out of Fusion and run it through SheetCam. And we played around with we varied the speed of the feed rates, the pierce time, the pierce height, and that kind of thing. But what you're going to see in these videos is that the torch height on the Languir systems, the way that this limit switch is wired up in the middle here, it just works. The torch comes down, touches off the metal, comes back up, turns on the laser, does a pierce, and we do some cuts. And initially we were starting with this piece here, and we were doing 1/8-inch cuts we have a 1-inch coupon, 1-inch square with a 1/4-inch hole in the center, and this is what we were cutting. And we went through and we did a bunch of testing, and we got up to 150 inches per minute of cutting 1/8-inch hot rolled steel. Which is great, and the amount of dross on the back is minimal. We'll show you that, and it comes off really easy with a floppy disk. So we decided to move to a 1/4-inch plate, and we changed our speed down. We basically kept all the settings the same. We changed our speed down to 30 inches per minute, and it cuts through, and it does a really beautiful job of cutting. This is what our 1-inch square with a 1/4-inch hole in the center of 1/4-inch, and it's like great. Dimensionally, we're a little bit off. We're a little bit off by maybe 3 or 4 thou on a 1-inch square at 1/4-inch, and it's it's like very encouraging. One of the biggest issue we have here is because this laser has so much power, it's very possible that we're going to burn through the water table, because we didn't run any water today, and during during our testing we did pierce a hole through the water table. So this is something that we're going to have to resolve here as well. But overall, our testing really shows a lot of promise to do this laser swap. But again, I'm telling you that I'm not going to go into detail about what I ended up doing. You should be able to figure it out from knowing the operation of these things, the normal operation, and looking at the electrical schematic that came with the laser and figuring out how to connect it all together. We do have a safety system. We do have a foot switch. We do have a foot switch here that we wired in, and the operator has to press this down in order for the laser to fire when you're doing a job. Okay, so you just enjoy some of these cuts, and we'll show you what we're up to next with this Crossfire Pro laser swap. Okay, thanks for watching.
Your glasses on.
Glasses on.
Glasses on.
You got the safety.
Safety. Ready?
We've got air pressure. Looks good.
THC is off.
Look at that. That was cool. That's a thing of beauty right there.
All right. Let's check out the.
It left a. Is that a thing sticking out, or is that just a side? Okay, it's just.
It kind of burnt the tile.
Did you hear the something like popped?
It went through the tile. Shit. I know what it was. It went through the tile, and I bet it burned the drain. All right, let's see what's. Shoot. Yeah, you can't cut tile. Bullshit.
Who said that? I was like, man, I bet you can.
Damn, that's gonna blow. Here, go pull that down.
Be ready.
Yeah. Yeah, we blew a hole in the table.
Oh my gosh.
They went through this tile like it wasn't even there. That's kind of hot.
Well, that's a tiny hole. You think it's still? Oh, it did go. Look at
Yeah, it's like right there. It's like right there, the hole in the table. Well, that blows.
that. You can plug it up. I'm sure.
If we only had a laser welder, we could just.
Right?
Just we'll have to learn how to weld stainless.
Huh. So much for that.
Yeah, that blows. I really thought that was going to work. Okay, well, that's a good test.
With some steel. Heck, we could probably just, yeah. I just need to cut a chunk to fit under there.
This is us doing manual stuff. All right, putting our steel back down.
Okay. Figure.
We're going to change the pierce time to 0. This is where it's going to go.
Yeah, it's a flat.
Go. No, hold on. Go about there.
Okay.
All right, you ready?
You ready?
Safety on. ISH off. Or torch control off. That's better.
Perfect. Oh yeah. That was nice. That's it.
We still burn a hole in this thing.
Did it?
No, I think that's from leftover from a previous cut. Yeah, that looks great. Here we go. Torch light is off. Well, I don't know.
It through.
Okay. Quite a bit faster than the old plasma torch.
And I love how we're not getting our tip hot.
Yeah.
Should be malignant.
Look at this one. Still looks about the same. It's hauling ass though. That piece is loose in there, by the way.
Good.
Okay, this is a 1/8 inch. It's a hot rolled steel. We're at 1500 watts, and we're going to cut at 120 inches per minute. Lasers on, glasses on.
Safe.
THC is off, safety's on. Is that loose? I can't
Yeah,
tell.
it's loose. The hole fell out immediately.
Okay, hold on. Yeah. Holy crap. How fast does this Languir go, man?
Yeah, we can be pushing it.
I don't think it didn't even mark it down here.
That's better. That means the energy's going into the part. We started out way too conservative. What, 4 times faster than we started?
Yeah, we started at 30.
Yeah?
We did this one at 30.
4 times faster.
Oh yeah, 4 times faster. Oh, that's a hottie. That one's hot. All right, so here's the kind of quality here. And we've determined that we're the Gerbil settings for this a little bit off on the x-axis. We're a little bit over by what?
8 thou.
1/8 thou over, but we're on the y-axis. We're on the money. So our kerf width is looking pretty good, and we have our laser lined up pretty well over here because we're not seeing any discoloration in the tip there. So the laser here has got a couple of adjustments on it. You can adjust this distance here when it's coming out of the gun. And I'll run this down a little bit here. When this nozzle here can be adjusted up and down, but you can't move it side to side. It's going to be centered in the middle of the fixture. There is, however, an adjustment in the top of the gun to kind of move the dot around. And the fact that this isn't hot down here, it's not hot at all, means that our laser width is actually, our laser beam is actually going right through the center of the little tiny nozzle hole down here.
Look at the improvement we made on dross.
And so we'll look at the dross here.
It's getting way better.
So this was the 120.
Yeah, the fastest is the least.
Okay, so here's the dross difference here. Do you think that this one was a 90?
That was 60, I think.
Okay, so this one's 60. So if you want to see the dross here, it's well, the dross on all these is quite significant here.
This is 90.
And so that's that one. So here's the dross on the 120. It's significantly less, which is great. So all right, so we're going to continue upping our speed until we fail.
150 up next.
DHC is off. We're at 150.
Okay.
Safety on, laser on, glasses on.
Yep.
This is 150.
It's through. We just found our.
Wow, that is tiny kerf width there. It's tiny. You give it a hammer. That center is loose. That's good. Yeah, there's no mark at all down here.
Does it draw something?
There's still a little bit of dross on that, but it's nowhere near where it was.
Manageable at that point.
Wow. This is a 1/4 inch. We're not even at 2,000 watts yet.
It's 1/8 inch.
This is an 1/8 inch. Sorry, 1/8 inch. All right, cool that one off over there. All right, continue on our quest. What are we doing? What are we doing now?
Yeah, I don't know.
Oh, this piece over here isn't even hot. Our stock isn't even hot.
Where is the center? See?
Holy cow. All right. Let's slow it down to like 130. Let's get it to, so let's go to 135. Let's go to 135.
Man, that dross is so manageable now. Man, it was on.
It's loose. That came out a lot easier than the other one. I think it's pretty good. Myself, I think this is great. Yeah, this is friggin' awesome. All right, so that's one side. It's supposed to be 1 inch here. So that way is what?
There we go.
That's 1.09.
Yep.
Okay.
And if you go on the top,
If you go on the top, it's a little lower.
yeah, it gets down.
Yeah, okay, so that's our beam width there.
Yep.
And it's up 1.09 there
It's still,
as well.
Yep.
So we could still tweak it a little bit. You think that's a kerf problem?
Yeah, we could probably adjust the kerf a little bit.
To what? Which way are we gonna go?
Well, we have 10 thou in there now, right?
We have 10 thou in there now. You think it's narrower?
Well, if we want the overall part to be right with the flare, we'd want to go almost to 0. Like 7 thou smaller, basically. 8 thou.
Really?
Because overall, even with that little bump, 1.14 by 1.08.
So what should we make it?
Well, if we want that to be 1 inch, it'd be. We're at 7, so it'd be 3 thou.
So we're gonna change it from 10 to 3.
Sure.
Okay.
That'll get us closer.
All right, so we're gonna change our kerf width to 3.
It just means the top will be a little
Little under.
Yeah.
Yeah, if it's yeah, that's fine. Okay, so this is
135.
this is 135 1/8 inch. We changed the kerf width in sheet cam to 0.003. We're going to measure the overall distance and look at the kerf distance from the top to the bottom. So safety's on. Ready?
Yep.
That's a little hot, but it's not very hot. There you go.
It's still, yeah, it's still a little big. Although if you go just above the dross,
Go just above the dross.
Yep.
It's fine.
that's right on.
That way, and then this one's
This one's still a little big because of the
On the
X,
X.
but it's
Yeah, but I'm
better.
Yeah, well, we're not going to tweak it for that.
nope,
We don't need to tweak it for that.
nope.
All right.
Wow. And the dross is definitely looking good.
All right. Let me we'll whack that dross off, and then we'll show you what it looks like when it's cleaned up. All right. So we knocked the dross off of this. We didn't actually knock it off, right? We bent it over, so this bottom side has this. There's a little bit of an edge right here
Yeah.
of 3 thou. So you can feel it. It's pretty pronounced, particularly on this edge right here.
So we sand it a little bit on the edge too if we wanted to, but frankly, unless we're doing a perfect fit kind of application.
We're not. Yeah. Yeah, it's awesome. Yeah, so if we sanded this down a little bit, we can take that edge right off.
Yeah.
It does kind of feel it right there. Okay. And then over here, nothing.
Nice.
I mean, there's a little bit of,
I'd say we were just going a little too slow.
you think we're going too slow?
No, we originally.
Originally. Yeah, for these original cuts, we were going way too slow. All right, cool. So here we go. Did you see anything?
I think there's enough rust, which is why they do that pre-clean pass.
Oh, really?
Because it was definitely deflecting on a few points.
Oh, so it's not in through yet.
Yep.
Not you. Yeah, it didn't get through.
It'd be interesting to do a quick.
Oh, it didn't. It really didn't get through at all.
Yeah. I can see a deflection.
Yeah, this whole thing down here didn't get through at all down here at all. All right, so I'll take it over and blow a blast of rust off of this because this is pretty rusty.
Yep. What's the backside look like? Yeah.
It's worse.
If only we had a laser cleaner.
We're not taking this off anymore.
I know.
Okay. Glasses on. Zero in your car here. It's zeroed out. Laser on, glasses on.
Yep.
Safety on. THC off. Zeroed out. Here we go. Oh, that's good. Whoa. That's good. Oh yeah, the hole fell through.
Is there an overlap amount? Do you have that on?
It made it worked.
Yeah, through.
It's gonna fall through. Probably run that a little bit slower.
I really think it's just the lead in, lead out.
Yeah. There's very little marking down here.
Okay.
There's a
You want to pull that off?
there's a little there's a right where it started. It's shinier down here. Wow, that's awesome. All right, let's go measure. Let's cool that off and measure it up. Yeah, so the lift's still there. Our kerf width was still. We have it still set at 3 and 3 thou in sheet cam. That's watch, this is gonna be right on the money. A little bit higher.
That's right in the middle of the part.
Okay. All right.
Not bad at all.
No, it's pretty good for a 1/4 inch. I didn't clean that. Perfect. Okay.
Wow.
Yep. That's
That's
nice.
pretty freaking awesome.
That is nice. I think with our testing today, we've been pretty successful. There's the 1/4 inch fit up for a 1/4 bolt. That's nice.
It's perfect.
All right. So that's good. Yeah, I'd call this a success.